Okay, Assalamualaikum warahmatullahi wabarakatuh. Our group want to present broadly defined problem project BNE43103. Our group members Muhammad Aiman bin Halim, Muhammad Aiman bin Haji Ishaq, Ahmad Irfan bin Ahmad Syukran, Muhammad Nazaruddin bin Jumali, Nurul Izzah binti Abdul Razak. First, my name is Ahmad Irfan bin Ahmad Syukran. I want to present about introduction first. Protection scheme are very important for all distribution system. Electrical power engineering has a specialty called power system protection that deals with protecting electrical power system from problems by cutting off faulty components from the rest of the electrical network. A protection scheme goal is to maintain the power system stable by isolating just the faulty parts while keeping as much of the network operational as feasible. Protection devices are those that are used to safeguard power system from error. Among the very important equipment is the protective relay. Protection relay are key components of the electrical power grid that detect faulty equipment or other dangerous or intolerable circumstances and may either begin or authorize switching or just send a warning to offer a safer, more dependable delivery system. So we choose inverse infinite minimum time ADMT over current relay as our group project. This is the principle of a current with inverse definite minimum time IDMT. A relay has an operation duration that is roughly inversely related to the fault current close to its pickup value before becoming constant above it. Near pickup value, the relay has inverse relationship between operating time and fault current and becomes almost constant just above the pickup value. IDMT relays are frequently used to protect distribution lines or distribution feeders. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izzah binti Abdul Razak. So I will explain about the problem statement. So the problem statement for this project is to design and develop an appropriate protection scheme for a two-source distribution system. The system likely involve two separate sources of power that are connected to a common distribution network. So the challenge in this project is to develop a protection scheme that can detect and isolate faults for abnormal conditions that occur in the system, while also maintaining power delivery to customers. The protection scheme design will be able to identify the type and location of faults such as short circuit or overloads and rapidly isolate the affected portion of the system to prevent damage to equipment and ensure the safety of personnel. So overall, the goal of this project is to develop a protection scheme that is effective, reliable and cost efficient, and that meets the specific needs of the two source distribution system. This will require careful analysis and consideration of the system characteristics, including its power source, load profile, fault currents and other relevant parameters.
Hai, Assalamualaikum warahmatullahi wabarakatuh. It is Muhammad Nazaruddin. So I will present design and calculation for our project. So the type of relay that we are using is inverse definite minimum time IDMT over current relay. So this is our design. We have two generator, 4 bus bar, and we have 8 circuit breaker, that is R1, R12, R21, R23, R32, R34, R43 and R4. So we have 4 feeder, L1, L2, L3 and L4, and 1 transformer STX. So the fault that we expect to be happen is at the bus 1. So the calculation, so this is the rating set. So the rating for generator 1 is equal to generator 2. This is equal to 50 MVA. It's 100%. So the time multiplier setting is 0.3. CT ratio is 800 per 5. The I fault is 1600 ampere, and the rated current is 5 ampere. So the ROT formula, rate of time formula, is equal to TMS multiplied by 0.14 divided by PSM, plug setting multiplier, power of 0.02 minus 1. So for the PSM formula is equal to IF secondary over IR multiplied by current setting. So to find the IF secondary is equal to IF over the CT ratio. So for the first one, circuit breaker R1 and R12. So the setting current is 100%. So first we have to find IF naught is equal to 1600 over the CT ratio, that is 800 over 5, that equals to 10. So the PSM is it will be a 10 divide by 5 multiply by 1 is equal to, so the ROT we put in the formula, so we got 3.01 second. So this for the circuit breaker R21 and R23, the IF is equal to 10. The PSM plus setting multiplier is equal to 1.6. The ROT we get is 4.47 second. Next is for the circuit breaker R32 and R34. The setting current is equal to 150%. So the IF still equal to 10, but the PSM is equal to 1.33. So the ROT will be 7.34 second. And then lastly is the circuit breaker R43 and R4. The setting current is equal to 175%. The IF is equal to 10. PSM is equal to 1.14. And the ROT is equal to 16.01 second. So I think that's all from me for the design and the calculation. So we will go to next. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. So my name is Muhammad Aiman bin Halim. My matrix number is DN200055. So for today, I'm going to present about the reason why the circuit breaker have a different timing time. Alright, so we need to understand that a different position of what happened will give a different result. And for this situation, it happened at bus bar 1, okay, as we can see at the circuit above. And the circuit breaker R1 and R2 have the shortest tripping time. This is because of the location of the fault is closer to the R1 and R12, okay, for the circuit breaker. And the tripping timing for these two R1 and R12 circuit breaker is 3.01 second after the fault occur. And next, the second shortest time is the R21 and R23 with 4.47 second after the fault occur. Then the circuit breaker R32 and R34 is the second lowest to trip, as the tripping time is 7.34 second. Then the circuit breaker R43 and R4, that the tripping time is 16.01 second, and it make that this circuit breaker is the lowest to trip because of the distance of fault to the circuit breaker is far.
Alright, next is the block diagram of this proposed relay design. So this block diagram consists of 6 main components. The first one is current transformer. So the current transformer measures the current flowing through the power system and convert it into a proportional low level signal that can be used by the protection relay. Next is voltage transformer to measure the voltage level of the power system and convert it into a proportional low level signal. Next, overcurrent protection to detect and isolate faults caused by excessive current flow in the power system, such as short circuits and overloads. The next one is over voltage protection, which is to detect and isolate fault caused by excessive voltage level. And then protection relay, to receive input signal from the current and voltage transformer and the overcurrent and over voltage protection modules. And the last one is circuit breaker, a device that can rapidly interrupt the flow of current in the power system in response to a fault or abnormal condition. It is controlled by the protection relay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Haji Isa and I will present about the design simulation and the data analysis. So the figure show our design of simulation that we use ETAP software. So we have 2 generator, 4 bus and 8 circuit breaker, 3 relay, 1 transformer. So we set the circuit breaker as the output for the relay. So this is the graph of the simulation, and this is the result when the simulation will run. So when we put the fault current at the bus bar number 1, the circuit breaker 1 and circuit breaker 2 will trip because this is the output of relay 9. So next is the data and analysis. So ETAP will display and simulate the flow of the load through the circuit connection. So in the simulation, we set all of the circuit breaker to be the relay's output. As a result, when the relay is triggered, the circuit breaker trips and the fault current is located at bus 1 for the project. So as an outcome, circuit breaker 1 and 2 will trip because they are set as the output of the first relay. As a result, the simulation output match the calculation result that we need. So that's all from me. Thank you.
So next for the conclusion, and as a conclusion, the system purpose is to trip a circuit breaker in incidents that if the defect is found, and because of the priority of which circuit and equipment must be protected, a protective relay must respond and trip a breaker within a few thousand of seconds. And to analyze the functionality and stability of the protection system, a program testing and simulating must be performed. And for the PMS and TMS value, it must be meet the standard of SI properties. And for the calculation and simulation that shown in the above slide, okay, in this assignment, it showed that a larger TMS slow PMS clearing time, and no matter the TMS result, either it positive or negative, and to build and operate operating system that meets society needs without endangering public health or safety, relay must be done properly, and electrical component must meet technical standards.